since, yeah, Azimuth, Urbit ID is the last frontier of all of this. Ironically, right? Because that's often the way that people first get into Urbit is by playing with the ideas around identity and what's going on with it. So let's look at, I guess, let me go ahead and share a text editor. Which would be, I think, this one. Yes. And I better keep participants in chat open. Man, I would kill for a window manager that could just remember, like, open these windows, move them to the right spot on your screen. No existy. All right, Azimuth and Urbit ID. All right, so we'll just kind of start top level there. You know, there was a push probably about 2-3 years ago when they were thinking about, well, maybe we'll simplify the branding of Urbit and just have Urbit OS and Urbit ID. And I think the urbit.org, the main landing page, still leans pretty heavily on this. But of course, as soon as you're into the system, that's not really an adequate terminology to describe everything that's going on here. So Azimuth is more or less synonymous with what we mean when we would introduce someone by saying Urbit ID. It's the part of the system that allows ships to have a unique identity, to securely communicate over AIMS peer-to-peer, to have encryption, and to construct a sponsorship chain, which is how you get galaxy-based routing and your initial set of updates. You also have direct routes, which are stored in AIMS once you know them, but you don't have them initially. So Azimuth is a PKI. It's a public key infrastructure. And one of the really nice things about Azimuth is that it, as a PKI, it solves a problem that dates back to the cypherpunk stuff in the mid-90s. So you remember, I mean, you may have read Cryptonomicon, and that gets in some of the similar ideas in that novel. But you know, there's the Snowden leaks, and a lot of these communications were done using GPG, which is the GNU implementation of PGP, which is pretty good privacy. It's an encryption standard. And what PGP would let you do is it would let you generate a key pair where you have a public key and a private key. They are symmetric in that it's a social or a semantic convention that you're calling one public and one private. They're simply two keys. And depending on the information that's available, maybe each ship communicates or computes what their shared, each party, I should say. I'm not yet talking about ships, but each party can compute, or one party computes and then publicizes, and then the other one can use it. There's a lot of different use patterns that you have there. The problem that PGP always had, and this definitely was an issue up through the rise of things like Signal, certainly, is that it was so hard to use correctly that people would try to use it and they would use the wrong key, or they wouldn't encrypt it correctly, which meant that their message was garbled, or they wouldn't encrypt it correctly and their message would leak. And there's a couple of cases of people who suffered pretty severe repercussions from that failure to encrypt properly. PGP was just really hard to use, like in practice. Like it's a good idea. It's saying, we're going to have two keys, but in practice, it was this kind of hard to use command line tool. And so people started to build up more and more pieces to deal with this. The genius of a public key infrastructure is that it allows you to generate the key pair and secure it some way on your end. And then that public key is simply published. It's available. Anyone can see it. Anyone can verify it. And now you're able to sign anything with your private key, and they are able to decrypt it using the public key, modulo the way that the particular encryption system is set up. So what Azimuth does then is not unique as a PKI. It solves the same problem that PKIs were set to solve up, but it couples it to the finite identity idea. So you have public keys bound to entity identities, and each entity holds its own private key. And so when we talk about what Azimuth knows, right? Azimuth is a PKI. So Azimuth has to know 3 things for each point prior to publishing a key, like knowing anything about a key, generating a key, publishing it, whatever. It needs to know the identity of the point. And so the raw value is simply the number that you have, which of course we use mnemonics for. The life, which is the key revision number, because you can rekey without breaching, and you can make decisions about revising your keys somewhat independently of the network breach process. And you have a rift, which is your continuity number, which is the number of times that you've breached on the network. Azimuth publishes, it has this information publicly available and has a key associated with them. So if we saying like, what is the actual Azimuth state? It's basically a map of identity, life, rift to public key. These are then used by Jael and Azimuth, or excuse me, and AIMS to ensure that your communications are always done with the most recent set of networking keys. So whenever you do an operation, one of the things that you try to do is you try to send a message, and if this message fails for some reason, I don't know exactly when it happens, if there's a timer or what, but Jael will be informed by an agent watching Ethereum as its source of truth. Oh, someone's breached. Mark their old keys as invalid, throw them away, and next time you need the new keys, request them so you have these available. So technically, Azimuth is currently instantiated on Ethereum as an NFT, as an ERC 721 token, which has formally what that means is that it implements certain contract arms, right? Functions, right? I shouldn't say arms, certain contract functions. Is what makes it an ERC 721. So Azimuth was the original Azimuth was a spreadsheet that Tlon maintained. And then around 2019 or so, they moved to Ethereum. And the original Azimuth was then layer 1 on Ethereum. And so what this meant is that transactions in Azimuth state are directly computed on and verified by the Ethereum virtual machine. And more recently, when we added a layer 2, what this does is permit batch transactions very cheaply, but these are no longer computed on EVM. They have to be computed on Urbit and then uploaded as basically we're attesting these are correct, but the computation is not verified by Ethereum. This also has the cost of external visibility, because you have to have, in practice, you have to have a running ship that can get the JSON, run a JSON agent that requests this information for any particular L2 ship. There's some interesting technical governance aspects of Azimuth. More than any other part of Urbit, Azimuth is the thing that the Galactic Senate governs. They have oversight on chain state and contract exploits and everything. I guess the other thing they govern is the composition of the leadership of Urbit Foundation. But like, for instance, they don't really touch core development or these kinds of things. So there's an interesting safety valve, which is explicitly built into the system, which is that Azimuth has a state on Ethereum, but the Azimuth that can be Azimuth is not the true Azimuth, I suppose. The Galactic Senate could actually, like if there were a the DAO like attack on Azimuth, then the Galactic Senate could still override that chain state. I imagine this would be, enormously controversial, but the Galactic Senate is sovereign in that it can determine exceptions to what the Ethereum claim about the chain state is, if there were ever circumstances under which that would make sense. We are not really going to discuss layer 2 points. From Jael and Ames's perspective, they behave the same as L1 points. So the details of their use are largely just a matter of making sure that you check the right technical points. In general, if you're going to be building tools on Urbit that need to know, or tools that work with Urbit that need to know about Azimuth, you should be running a ship, and you should just be asking this information from the ship, because the ship will know how to get this information. You don't want to get it directly from the Azimuth contract state on Ethereum. All right. So you are doubtless familiar with the old fivefold hierarchical nature of Urbit ID. It's worth knowing. Let me see if I can get this to fit across. Basically, there are some historical names for what the different tiers of points are. Sometimes you'll run across these in reading very old things. So Galaxy was a Duke, and then it was a Czar, and then it was a Carrier, and now it's a Galaxy. A Star was an Earl, then a King, then a Cruiser. I really liked Comets as Wolves. I thought that was a good one. So originally they were forts, and then they became ships. And anyway, there's all these weird metaphors there. One of the problems that I think the astronomical metaphor solved for us really well is when you look at these, is a Duke higher than an Earl? Like if I were asking you and you weren't looking at this chart, would you be able to answer that question for me?
Couldn't tell you.
Right.
Like even Czar and King, doesn't Czar mean king?
Well, I mean, a Czar is an emperor, which formally is over a king. But, we run into a lot of problems.
Yeah.
What?
No,
Yeah,
I agree with you though.
But right, guess, like these are opaque.
Yeah.
And the ships have the same problem. Like, okay, a carrier is the biggest, but like, why is a cruiser, like, what's the relative hierarchy of a cruiser and a destroyer? Right? Like, I mean, am I thinking of like Battleship? Am I trying to remember how many pegs these things have? So when I first got involved with Urbit, I was involved briefly in 2016. I downloaded and got a submarine to try it out, but it was unusable then, so I dropped it for 3 years. You were going to say?
Just knowing the relative importance of a yacht and a submarine also. It's like, I don't know which of those would be above the other, really.
Right. And Zod was originally Pope, too. Like, Zod was special cased as Pope. So you need to know these for 2 reasons. One is that they're actually still in the kernel. So if you go look around in Zeus or wherever these things are, maybe these are probably in Lol, I don't remember offhand. The names that are used internally are still Czar, King, Duke, Earl, Pawn. So if you run the clan title agent, let me see if I can get a. Let me see if I have it's a second. I have to close my other Zods. Thou shalt have no other Zods before class. All right. Right. So if you ask it what your clan is because you want to know your rank is going to come back to you in this middle era terminology. It's no longer a wolf, it's not yet a submarine, and it's definitely not a comet. So there's a few odd places where if you're doing checks, you have to check against these. In practice, what I'm seeing now is much more common is people are just doing I guess it'd be less than or equal to, something like this. Right, is hour less than or equal to the width of the galaxy space. The other interesting thing to notice about the namespace is, of course, that only galaxies actually have a clean power of 2. Right, there's 256 galaxies. The stars have 2 to the 16th minus 2 to the 8th, because you have the galaxy carve out. The planets have 2 to the 32nd minus 2 to the 16th, and so there's all these not quite powers of 2 in the rest of the namespace size. I mean, I guess if you had forward padding, if you could 0 pad things, then you wouldn't necessarily have to have that, but then you'd have other interesting ambiguities that would get introduced into your system. Yeah, and so how are we actually telling how, like, what something is? What do you remember what net does? This one goes way back.
It tells you the bit width of the noun.
Yep, in the power of 2.
In the power, yeah, in the block size, yeah.
In the block size, yeah. So this is bytes. So if you can fit it in 1 byte, it's a czar, it's a galaxy, and so forth. Let's see. Let me find Zeus here. Zeus has a number of arms in title. Here we go. So there's your clan designation. There's your rank. Your name gives you who you are. Your Saxo gives you the sponsorship chain. That's actually an interesting one to see in many cases. A lot of these take maybe Saxo. I think there's 2 Saxos and they have slightly different interfaces. Yeah, this is the Saxo you see from the outside. Then there's an inner Saxo here. Stateless queries. I don't know what the difference between the inner and the outer. Okay, so surface core for user space. Okay, so our now we ignore, and then we want to know some ship. So let's do like mid-dev. And so this gives you the sponsorship chain of what we should call the natural sponsorship chain. All right, why do we distinguish a natural sponsorship chain as a special case?
You can escape your star, right? Whatever your natural star is, that, like, if you're a planet.
Yeah, but why would we say natural star instead of just your star?
You're a fake Zod, so you don't have access to the actual
No,
state.
it's not that.
Oh, okay.
I'm doing the bad teaching thing where I'm like fishing for a specific answer with a question.
It's just like what's default.
Well, do you remember Emancipation?
Not specifically.
Well, so you can change your sponsor.
Right. Yeah.
Right. So I can change my sponsor by asking, who actually is my sponsor. Where did I come from? Now it looks like this is actually scrying into Jael. for that information rather than calculating it. So I may be wrong, and that may not actually be the natural sponsor. That may just be the actual sponsor. I'd have to boot something and check. Gosh, what's I think my star, actually, let me try this. Let me try this. My star is emancipated. It's very, very forward thinking. Let's try this. Because the galaxy that it was under is not booted. So let's see what this gives us. Does this give me Bell, or does it give me? Oh, it gives me Bus. Okay, so this is the actual sponsorship chain. Okay, so it's not just the mathematical who you nest under. It's if you've emancipated to someone else, change sponsorship, it gives you what your actual route is, which is great, because that's from a routing perspective, that's what you actually care about. Let me actually edit that in the notes, because I had that backwards there. All right, let's see. Points. All right. So galaxies don't have sponsors, right? They have a public key that's visible in Azimuth. They have an IP address that is static. There's actually a whole section of, I think, operators.urbit.org on how to boot a galaxy properly. You've probably never mucked around in that part of the docs. I had not really before either. But there's a whole section, because you have to register the IP address with Urbit Foundation, because the IP address is loaded on boot from a galaxy table. You remember that part from, September, that the galaxy table gets loaded when you boot in the runtime. And then you can build your sponsorship chain by construction, and then you can build routes. So that's like enough information. So galaxies have to provide that. And then other points, stars and planets, are in Azimuth, and so you can obtain them from Ethereum, and they're stored in Jael. And it's basically Jael stores a point. It stores its point. It stores its sponsor. It stores its life and rift. So that's enough information to locate it, even if something goes down in the chain. Moons do not have an Azimuth presence. They rely on their parent ship's Jaels to track their life and rift values. And so that's why you have like a moon cycle key and a moon breach operation on your ship, because your ship is the source of truth. It acts as the Azimuth for all of your moons. And then similarly, comets do not have a registration in Azimuth. One thing this means is that they can't cycle their networking keys. Possession of a comet is possession of a comet, and they can't breach. So their life and rift are always 0. Comets cannot communicate with each other directly. They can both talk to a moon or a planet or whatever and communicate that way, but a comet cannot talk to another comet. And this is because a comet, the first contact a comet makes with someone on Ames is an unencrypted self-attestation packet. And then once you know who those are, then you can generate keys, mutual keys, and start communicating. Moffel says soon that will be 100% true. Do you want to expand on that?
With the new MDNS change, if you're on the same network locally as another ship, another comet, you will be able to talk directly to them.
Okay.
Right? Because your Ames changes now to not go directly to the galaxy for peer discovery, but if you're on the same network and it has an MDNS record of you, I'll try that first.
Right.
Yeah.
Okay, that works.
Yeah. It's kind of cool. You can have local anonymous networks with comets.
Do you remember Leak?
I don't.
Okay, Leak, Leek. This was a spec I wrote up a while ago as a possible homework for App Workshop that no one ended up biting on. But it was a way of building and anonymizing like a Tor-like routing network by bouncing between comets. And the problem with it is that Comet self-attests, so you can't initiate this process. But once you can, now you can actually use this to build Tor-like nodes on Urbit and anonymize messages.
Okay.
So, all right, that's high-level Azimuth. Okay, let's talk about the instantiation of Azimuth. So Azimuth is instantiated as ecliptic. This is the actual set of contracts for Azimuth. There's an azimuth.eth and an ecliptic.eth that are separate from each other. Azimuth is contract data store. And ecliptic is operational contracts. So this is how you do transfers, how unlocking, all these things happen. It's different from Azimuth so that if you need to upgrade the contracts, you don't lose the information. It's not envisioned that Azimuth will ever need to contain any other information than what it has today. Like what it knows is sufficient, should be sufficient for all time on Urbit. But ecliptic, has been upgraded. That was one of the first trials of how do galaxies vote. For instance, a couple of years ago was they needed to do some upgrades to the ecliptic contracts. And it protects us from losing state on azimuth.eth by separating these. They're all written in Solidity. So, if we want to go look at them, it looks a lot like JavaScript, right? Because that's what Solidity is. There's a whole set of them that gets invoked for various purposes. So there's Azimuth, and there's ecliptic as the interface. Then there's a poles, which is galactic Senate only. There's linear and conditional star release that are both smart contracts for how do you release stars. So if you haven't run into this before, stars are gradually unlocking. Like not all stars are actually available on Urbit today. Like you cannot spawn all of them from Azimuth. What was the first year they started having stars unlock? Do you remember 2020 maybe? I don't remember what year it was, but the first year you could unlock from a galaxy, you could spawn 1,000 stars, and then the next year it doubled, and the next year it doubled, and then it goes until all stars are available. I think all stars are available in 2025. So those are proceeding normally. I'm not actually sure if we actively use conditional star releases right now, or if we just send them when milestones have been hit. Claims and censures are kind of related to each other, which is just identity and reputation management. Delegated sending, I think delegated sending is something specific, and I don't remember what it is offhand. Planet sale is not actually a contract that's stood up that you can interact with. It's an instantiation of here's how you would transfer planets, as an example, a code that you can go play around with. Oh no, wait, actually I have it written down here. Beginning 2019, spawns may spawn 1024 planets. This limit doubles every subsequent year until the maximum is reached. Yeah, okay. So I think we run out of, like all planets are available by like 20, or excuse me, all, oh, that's planets, not stars. Oh no, I told you wrong. Let me read this. There's no limit for galaxies. For most galaxies, all stars have already been spawned and placed into one of the lockup contracts. Okay. So the galaxy contracts, the galaxy stars are in the linear and the conditional star release. But it doesn't say how many are in each. And then beginning in 2019, stars were limited on how many planets they could spawn to 1024. And then that doubles until the maximum is reached. Anyway, I think the whole namespace becomes available in the middle 2020s. In some ways, that feels like a little bit early to me when I've been thinking about the game theoretic aspects of all this, but I guess investors and the like would also see that as the ability to have the option of exit if they wanted it. Okay, so what bridge is, when you run bridge, you can run your own bridge. You can go to bridge.urbit.org, whatever you want to do. Bridge is simply a view into most of this information. I think Bridge doesn't tell you anything about censures right now. But this is, Bridge is just, it's a wrapper around executing ecliptic contracts. And so the kinds of things that are doing are just built on top of that. Now, all of this uses the Urbit HD wallet. All right. So HD is hierarchical deterministic. And what this means, so an HD wallet in general, like Urbit HD wallet is a kind of HD wallet, but an HD wallet is a system of related key pairs with specific powers. So there's a master key pair, and then it's used to deterministically generate auxiliary key pairs that have particular capabilities on a given chain. So your life cycle for this looks like, as point owner, you're going to get some means of claiming a point on Azimuth. So you're going to be sent a claim code or an email, or there's simply a transfer to an Ethereum address, or someone hands you a paper master ticket, or whatever it is. You have this seed that you use to make the claim. From that, you can either hold the point via the ownership address on Ethereum, or you could hold it via the master ticket, which has a seed PAT queue. Those look a little bit different from each other, but in both cases, basically, if you have the master ticket, it's associated with an Ethereum address, but you don't sort of really know what the details of that Ethereum address are, because you can do everything you need to do with the master ticket, ultimately. The seed is a PAT queue. All right. So if you go and write a PAT queue on some value like entropy, all right. So what what does that look like, right? Right. That looks like the comet from hell. PAT queue is simply a syllabic way of writing something, but it doesn't have any limitation on value or range, unlike that implied by PAT-P. So there's a lot of things that you can write as a valid PAT-Q, like this. This is 512 bits, so it's far, far, far larger than the Comet namespace. And I think there's some weird behaviors you can get out of it too. With let's try maybe it's not so. I think there's a way you can get it to what's that reduced to? 4608. No, Dopsod is valid. Dozod. Anyway, there's a way that you can make it. Well, okay, I'm not seeing it there. There's a way you can fake it out by giving it leading zeros and stuff, and get it to behave differently than a PAT-P would behave. I guess one of the I guess one instance of that would be a planet name must always be 4 syllables, but a PAT-Q doesn't actually care. So I can have a fess fit fess as a PAT-Q. And if I were to do the same thing as a PAT-P, then it goes and resolves to whatever the 4 syllable, in this case the mangled, obfuscated version of that name is. Anyway, so your seed is a PAT-Q, and part of the reason for that is a PAT-Q is an arbitrary bit width. So it's mnemonic, but it's arbitrary bit width. The key pairs that an Urbit HD wallet generates are There's going to be an ownership key pair. That's the main one that you have. That's your master ticket. There's a transfer proxy, which is only used currently on a temporary basis for transferring points. So this is what lets you, you're sending a point to someone and they have to accept. This makes it less error prone to have this two-step I send, you receive process to it. So that's what a transfer proxy is for. They're temporary keys and we don't really use them otherwise. Then there's a spawn proxy, which you would delegate to someone or some contract, some smart contract, when you want to be able to, when a galaxy or a star wants to spawn new child identities. So this is Galaxy Star only. Then there's a management proxy, which is, it can set life and Rift and it can manage sponsorship, but it has limitations on spawning. It can receive a boot key file. So this is what hosting companies use or should use. I'm not actually sure if everyone uses these today, but they should all use management proxies, excuse me, instead of ownership keys. And I wish Tiller were here because he would actually be able to give us some more insight into that. I don't know. I don't suppose you know anything about that, Mopful.
I think Red Horizons uses management proxies. I suspect.
I know Red
Twan does.
Horizon does.
Yeah,
I think Twan did not, because when they spawned, it was they were spawning with the ownership. But I think they do now.
Okay, and I don't know about Third Earth.
Yeah.
Or
yeah,
Holy,
yeah,
I'm sorry.
Yeah, right.
Yeah.
Right. I don't know what they do. I know I'm like trying to like remember what the hosting companies were and who bought them. What happened to them. Okay. And then there's a voting proxy for galaxies, where you can designate to some other contract or some other point where you get this. There is an app class command line tool which lets you directly perform key actions here. And so there's a lot of commands that you can issue here, and it uses threads. So like watch spider, right? So there's a thread to prepare a command and operate on these things. So there's a lot of pieces of class out there, but this is basically if you want to manually set these L1 actions. I think this is only L1 for class and doesn't do L2. But this basically gives you an unmediated glimpse at reality. Here's the interface to Ecliptic. Is baked in here. I don't know that I've ever really seen anyone actually use this. It probably gets used very internally when you're setting up lockup contracts and the like. But it's the sort of thing that you're typing raw bits into a blockchain. So if things go wrong, you don't have a lot of safety netting to do this. So it's like sudo. It exists. It's good to be aware of. It's good to use sparingly. Let's see what else with Azimuth. I guess we haven't talked about factory resets, right? So it's funny because all of the internal docs, all of the system components, everything calls it breaching, and then the network, they're trying to meme factory reset because it's like a more normie friendly phrase or something. I don't know exactly where it came from, but what a breach is, what a factory reset is it is a notice from an individual ship that I have forgotten who I am for some reason, like I double booted. We need to start over from scratch. It's a message to everyone that this ship has cleared its own event log, and everyone else should reset all of their networking information about that ship. So their Jael and their aims should throw away everything that they know about that ship. There are probably some interesting consequences in remote scry that I have not really seen addressed yet. And actually, as Gary and I have been talking about token, one of the things that we've had to do with token is decide how we are going to propagate forward in time remote scry attestations from previous Life Rift versions of a ship, which is an interesting problem to have. Because that, so you actually have to keep track of the keys that were on Azimuth but are no longer in the current Azimuth state. Like you sort of have to do an event replay of Azimuth to recover that, or you have to track it actively. Turns out we can solve this problem by tracking actively, because we can solve this problem by tracking actively because we don't need to know about Azimuth keys that existed before token came into being. But we do need to know about any Azimuth keys that exist after token exists. The other thing to know about a breach, which makes sense if you think about it philosophically, is that a breach happens to a ship, so it cannot know about its own breach. Right? It's like death. It's like the ship does not know that it has breached. Except if it, in a sense, if it looked at its life key, or, life rift numbers, it would know, but otherwise it doesn't know. There's no action for a ship to take on a breach other than a regular boot. In Ames, for instance, we can see what a breach handler would look like. So on public breach, handle continuity breach of a ship. So you receive information from a ship. And what this means now is we're going to go through our state and our event core, and we're going to check every ship, everything that has anything to do with the ship. And we're just blasting everything we know about this ship. Reinitialize galaxy route if applicable. Like this is just a checklist of throw away all of my messages pending, throw away all the acts that are in progress, just rip it all up and we're done. So that's an Ames operation here. And then Jael similarly. Well, I mean, Jael sort of just like knows like what is your current public key. So you receive a breach notification, but Jael just knows that, okay, now I have new keys. That's all I need to worry about. Let's see if we can actually find where this is called. Yeah, so this is when you receive a breach. Let's look for a breach. It's the only place it occurs there. All right, so breach occurs in it's all Aqua stuff. Yeah, so that's a Jael result is the breach. This is the source of a breach, ultimately, is Jael. Which is great because Jael is the next thing we need to talk about now. And as you can see, everything that Jael does is rather short. It's a little bit more involved than because it has like moon management and stuff. It has to manage several different kinds of ships, but it's also not a terribly complicated vein. So Jael is going to store Azimuth information, and Azimuth is basically the exoteric view. Jael is the esoteric view. What I mean by that is Azimuth is a publicly visible, here's all the keys, here are the addresses or whatever that's associated with them. Jael is saying, I know that information, I've obtained it somehow, but I also know things like what are my private keys? What do I know about cryptography? What do I know about the moons and the things that are local to me? What do I know about the comets with which I've communicated? So all of these things get set for Jael and they're not necessarily part of Azimuth. So Jael as a vein is primarily concerned with networking management between ships, in that it provides information for AIMS to use, and Clay via the remote scry stuff too, and cryptography. It also supports different promises and deferred kinds of requests that you can make for things. Jael is going to know about state in two different ways. It's going to know about absolute state, which is everything that's known about Azimuth PKI, ship ownership, your private keys and everything. And then relative state, which is everything that you know about your current ship and your moons and these kinds of things. Azimuth is okay. So for instance, I have, sorry, I'm looking for one of these tasks. Yeah, listen. Okay. So Azimuth is set to take its truth about the network in a particular format from somewhere. Azimuth actually doesn't know about Ethereum at all. It knows about a series of agents. Well, it knows how to listen. And then there's a series of agents that retrieve this information from the from Ethereum nodes, formatted in the right way, and then submit it to Azimuth. And so that's the part that actually knows what's going on. So if you changed listen, if you changed aspects of this, you could kick Jael over to talking to an entirely different source of Azimuth. So you can imagine this as a test net or your own private Urbit, or whatever thing it might be. This is just what you do. You just rip out one source of truth, put in some other source of truth. Now, of course, everyone communicating over that source of truth would have to share it, but it's, in a sense, it's straightforward. All right. Questions up till this point? We're going to get into this interface and stuff a lot more too. All right. Then let's look at, I'm going to reorder I have a reordering of these that I like better. All right. So I've sorted these tasks differently so you can sort of see, here are Azimuth-ish operations, here are key-ish operations, and so forth. So at the beginning, you have a dawn event when you do your initial boot from your key file that you downloaded. And then if you're a fake ship, then that's the override that happens from it. As I recall, these are both ovum that are injected as raw cards by dawn.c. So the runtime generates these. All right, see you. Merry Christmas, Amadeo. Then you have the set where you know information or keep track of things that's going on with breaching or nuking or what have you, just network management stuff. Then you have private keys, public keys, rekey, and reset. So private keys is something on your ship is subscribing to know your private keys. Pretty much this means AIMS. Your AIMS passes a special task to subscribe to private keys and do what it needs to do there. And then public keys are things you can make available to, about moons, for instance. You're going to keep those public, you're going to keep those visible. Perf is, I believe it is the set of, it's either the set of Galaxy domains or it's the registered domains when you do like an Acme registration. So, you know where the routing is going through. I don't remember offhand which one of those it was. There's one of the, it's a domain domain system management that in practice, unless you're actually mucking around in Jael, you wouldn't ever use. Moon keys, making these things available, and then your login code, change your login code. So you have a login code, but your login code has nothing to do with Azimuth or anything else. It's just it's a code that's written down somewhere. And then your regular bits and pieces there for dealing with everything. The kinds of things that Jael reports back deals with some AIM stuff, deals with private keys and public key changes, and then if there are domain changes and whatever the domain was. So basically it's a key dealer at the end of the day. As a vein, Jael exposes. All right, let's look at Jael itself. Jael has a state, and its state is, it gets called Lex where it gets defined down internally, but basically it's these two pieces of information. It's your known PKI state and your Ethereum node, your associated Ethereum node, so you can tell things where to look. You don't know what Ethereum is, but you have to keep track of like what's the state of connection. This is your stateful tracking of who you're talking to, even if you don't care if they're Ethereum or something else. So PKI is your actual metadata, right? Like here are the things you actually have to keep track of. In particular, there's your set for a moon. There's your set of are you a fake ship? Are you a live ship? What's your current life? What's your login code step? So your login code, if you change your login code, you're basically using this step as a salt to kick you to a next. It's deterministic, but you're just tracking it by how many times have I had to increment my login code request here, so you can rekey the code. All right, and then there's a lot of this is interface stuff for it to know how to talk to other agents. There's a lot of management cores for different things. Like Easy here is the Ethereum wallet operations that are sorted here. There's I guess order events is the only one that's in there. Well, there's this OF. Oh yeah, that's right. OF is the move semantics. So this is, I've gotten something. What am I going to do with it? Someone's poked me to subscribe. Someone's asked for my keys. All of this gets handled by of. So this is your top level engine. Then there is the SU, which is the subjective engine, which are all of the derived state. That's going to be the subscriptions and the actions. So let's go back to, there's some turf stuff. Ships with real keys must have domains. Those with fake keys must not. Okay, so it actually has something to do with real v fake registrations there. Okay. Yeah, so for instance, let's go to call. All right, so we call an adductor, whatever. Okay, so this is what our actual operation is going to look like. We're going to call of our timestamp and entropy on Lex. Lex is our state that we walked through, we defined at the top, but the name we give to it is Lex. And then the task and the duct that are associated with it. So it's going to be a regular abet pattern call. So if we go back to the other call, this is the call that gets handled here. And this is just a switch on what kind of task did I receive? Did I receive a dawn? Did I receive a rekey? Did I receive a boot fake? Like whatever this thing is, I have to initialize this operator here. So for instance, a nuke, right? So if you nuke someone, you're blocking everything you know about that ship. I don't want to ever know about that ship again. Do it for a comet or something. And so this is just a systematic, we're just going to wipe every bit of information in our own state here. And now it doesn't exist anymore. I don't know anything about it. And it's on some special list that, I'm not tracking it anymore. Rekey is, so rekeying is a subjective operation. Feels to whatever information. The subjective operations, this is update private keys here. This is in Sue. So like I said, this is the derived state and subscription management. So in this case, rekey means I check my own life, see what my chain life was. I get the actual information about what the chain information was. And then I notify everyone of my new private keys that I need to at that point. So if the network tells me to rekey, then I get this notification, I get this information, I double check the life to make sure that this is a rational operation, it makes sense. I update my own keys from that information, and then I notify everyone who subscribed to my private keys, which means AIMS, that I've updated my life. Right? You wouldn't do this with a rift, because as I said, with a rift, with a breach, it doesn't know about it, right? It's just gone. That information is gone. But with a key change, it does know about telling people that this has happened. This is also a very unique way. I want to point this out, that this is kind of an interesting way of using the abet pattern here, right? So actually, here's our 402. So we're actually calling the abet on this separately after we call the private keys and we got the core back. Jael is the only place I've seen this kind of pattern. I think it's just an artifact of the relative age of Jael as a vein. Like it's a mature vein in that there's not really much else that I need to do with it that I haven't already done. But it's an older vein. So it does what it does. It does one thing well and doesn't really need to worry about the rest of it. Sorry, my water just, my desk has a very slight incline, and the water ran down that incline. The cup like slowly slid down the slid down the coaster. I don't know why the bottom of it was so slick, but oh well. Once I knocked over a glass on my laptop while I was teaching live, and that was the end of class that day, because I had to go get it turned into IT so they could crack it open and dry out every component and see if it survived. And it did, but that was kind of a harrowing couple of days.
It's always the worst.
At least it was water.
Yeah, my buddy spilled coffee on a laptop one time, and that did not recover.
Yeah, that's a little messier. I mean, I'm pretty careful. It's not like my water is close to my laptop, nor did it get on my laptop, but I do that thing now, right? This is what happens in adulthood, right? Like you look at a scenario and your brain's always like turning like, what could go wrong here? You're like, okay, it's like with little kids, they're always like talking at the table and they're turning around. So at one point I established a rule that you couldn't put your elbow past your cup, which seems like really arbitrary to kids, and they don't like rules like that are really arbitrary. But of course, the idea is if you put your elbow past your cup, when you whirl back around, you're going to send that cup flying. I don't know if that ended up.
I like that.
I don't know if it saved any heartache in the long run or not, because then you always have the argument of like, don't turn your elbow past your cup. Your kids are just like, you're crazy, Dad. What are you doing? Like it's like the don't leave the pot on the stove with the handle hanging off the stove. That sort of thing. Like just it's
I've
like
never heard that one.
OSHA at home. Yeah, that's kitchen management. Right? You
So
don't want an arm hanging off, you don't want the handle hanging off the stove because if you walk by, you're gonna hit it.
Oh, I see. So hanging off like because you could
Like-
imagine like if you have a countertop and the stove is in the middle of it, it could be hanging off relative, like it'd be over the countertop, right? But this is like over the space in front of the stove. is what you
Right, like
mean.
don't let it hang off the front of the stove because you were gonna
I
bake,
see.
right? You always turn it so it's back. Yeah.
Yes, that does make sense. Yeah, you don't want to be like hitting it because it could be hot,
Yeah.
or you could knock the pot over or whatever.
It's all this OSHA stuff got drilled into me years and years ago, and now I'm always kind of low key watching for it. All right, let's see. Jael scries are weird. So for instance, they're so if I'm down here, that's the code for this comment. So if you steal my comment, now you know the login code for my comment. They're weird scries. So they're Senjay, they take no care, and the middle part of the beak is the path that you're passing it to. This is just another artifact of some particular philosophy that was had at some point. I'm not even sure. Let's trace that. It's probably, yeah, so here's the scry arm. So the scry arm just switches on what it calls the side, which is the middle part. Yeah, the Q dot beam. Why are we starring these? I mean, I guess that saves you introducing. Anyway, yeah. Boy, that's an old notation. Pamphas. Yeah, this is it's not as old as like the parts of clay that are really old. And I think it's actually pretty internally consistent as a vein, which is nice. It's an easy vein to read, but it's sort of like reading Elizabethan English or something. Like it's definitely an older set of conventions around what's expected here. Yeah, so there's your code. Am I able to see this information? Slami. Yeah, I sort of wonder if, where did why come from? Why is the Pamphas P dot beam? That's not quite the same thing as me. Is that wrong? The first thing in the beak is the name, isn't it? Oh no. That's because that's not who I am. I'm not Zod. Okay, so that's what's happening. I'm actually giving it a name that's not me, and then it's crashing. It's giving you the this one. It's giving you the sig. So that's why it's crashing on the response there from that scry arm. Otherwise, it generates the code. That's interesting. It actually generates the code in situ. It doesn't have the code pre-stored in its state. It generates the code because it knows, yeah, so like there's the salt, which is to add the step. So that's the step that we saw that we said was a salt earlier. So it generates it deterministically from our own private key with our life, salts it with the step, and then generates it here. And then never actually stores it as a persistent value. Every time you call it, you would actually have to get this value. And it's the end 6, which implies that this is actually longer than that. It's kind of interesting. Yeah, so then there's other, Saxo will tell you the sponsorship chain, wherever Saxo is. Yeah, so that would call back to the Saxo that we saw earlier. So that would be something like this. So list Pat P, J, and then whatever the Saxo is for any given given ship. Like, let's see what my sponsorship chain is as a Comet. I'm under Marzod and Zod. So that makes sense. Actually, it would be an interesting I'm not going to have you do this. Maybe I should have you do this. I'm not actually sure how much work this would be in the current system. And that's why I was going to hesitate. To set up Urbit so that you have a Comet sponsored by your own planet. Right? Like, what would it take to actually change Comet sponsorship?
Would this be like when I would use like an Urbit binary to boot up a Comet, that it would request sponsorship for my planet? Would that be how that would work?
Right, but I'm just not sure if there's anything that you have to do positively on the planet side to permit that the way that stars do now.
That would be interesting. Yeah, I don't know how hard it would be, but
Yeah,
because I don't know what stars have to do. Because they do like somehow there's something where they like accept comets, right? There's like they can explicitly list like I am accepting comets to be sponsored by me. And some like I don't know how many have that turned off, but there are some that do have that. Like
right.
there's some flip that they can switch, or there's some switch they can flip to make that happen.
Let's see. Well, maybe I'll poke around. Let's see. Only a star can sponsor a planet. Okay, here we go.
Too.
Or sorry, Comet. Okay, so it has to be. There has to be a star. I guess we don't know what some of these things are. Like the sender. So this is an assertion that the sender is a star. Anyway, it's worth playing with. Maybe I'll put that as an option to figure out. I'm not actually sure how much work it would be. It shouldn't be a lot of work, but I'm not sure which work would be required with being able to do that. Ultimately, it's probably pretty straightforward. It's just knowing where the knobs are to do that.
There's probably just a couple places you have to modify it to be able to accept the planet instead. Like those would be the two big components: is figure out how to make it a comet be able to be sponsored by a planet, and then also in the boot sequence, like just automatically send it to that planet. Those are probably the two big pieces.
Yeah. Can you boot a fake comet?
I've never tried. I would actually love to be able to do that, because when I'm like testing front ends or whatever, like the comet needs are super long, right? It's hard to like make up a fake one, but just be great to like put up a fake comet and test it out that way.
All right, so let's see. If I were going to do Urbit-F, there you go. Fake comets are forbidden.
So like, why? Don't see why that would be.
Well, that's another like. I mean, that's a pretty easy override.
You just remove those lines and see what happens.
Yeah. Okay. Let me put that. Let me put that as an option here.
That would be cool, like, because I would find that feature actually useful, like being able to boot a fake comment. Although the whole thing with like, this is the thing also with like stars and planets is that when you want to boot fake ones of those, you have to boot the whole sponsorship chain. So like,
Yeah.
you have to figure out how to get a comment to like submit to a particular star. Maybe you could like boot a fake comment and say like, please request your sponsorship from this particular fake star that I've booted up or something. There's a way to make it work, I think, but the fact that they're just outright forbidden is kind of funny.
Well, it would also be interesting to see if with fake ships, can you change the sponsorship chain?
Like after it's booted or before it's
Right.
booted?
Like can I boot fake ships in a regular the natural sponsorship chain? And then is there any notion that can I emancipate? I don't think I can because I don't have a local azimuth. This is purely routing between fake ships.
Right. Yeah. Yeah, I think that there's some other way that they. Yeah, there's no like PKI that they're grabbing from. I don't know. Like there must be some sort of like different infrastructure there to handle this with fake ships, but I imagine you can't be emancipated. That would only be my guess, though.
Yeah. I don't know. There's some games you could play with this. The fact that this is the only check on comments is pretty funny. It's pretty straightforward. Go nuts. Okay, let's see. All right, the last thing we need to talk about then, well, we need to talk about bootstrapping, but we need to talk about Azimuth data flow. All right, so Azimuth, okay, so Jael and Azimuth don't talk directly. In this case, there's going to be this set of agents. There's Ethereum, which is queried by app ETHWatcher, which populates app Azimuth, which is used by Jael. That's your basic workflow up and down. Ethereum is Ethereum. ETHWatcher is a generic Ethereum state listener. It listens for Azimuth because that's what it's set to listen to. But you could actually use ETHWatcher to watch for other, other things on Ethereum. So it's generic in that way. App Azimuth is what subscribes to Azimuth transactions in ETHWatcher, and then tracks these things, and it exposes a lot of this data via scries and subscription endpoints and everything. And then the things that Jael needs, it subscribes to Azimuth to app Azimuth to get, and then it has its own innermost source of truth. So then it knows about, I guess the main bits of information that you need from LOL. There's a lot of point algebra that's defined in LOL. It's not clear to me that it's actually necessary, but it's sort of it's a very completist view of what's going on in here. How did I end up with two? Oh, sorry. I was just wondering where that second /Jael came from, but that's because it was wrapping. Okay, that makes sense. I was like, how did I get two cores? Two arms. Okay. So public key results are the things that Jael communicates in, which is either here's all the points, here's a change in points, or here's a breach notification. ETHWatcher and Azimuth need to communicate in blocks, which is just the raw information about here are the things that ETH is telling you, and then it knows how to decode or request whatever it needs. And then the thing that ultimately we're storing are points, where the point is a rift, a life, which are just atoms. I think they're actually like there's like, you know, they do like a weird aura or something to them. Let's see if we can find. Oh no, they don't. They're just pat UDs. They're just raw pat UDs. There you go. Why aren't they something more complicated? I don't know. You know, pat UD Rift would be very in line with the way some of these other aspects of the system are written. Then the actual keys is a map of this information and the sponsorship. So yeah, you have that info. There's a couple of charts. One thing to keep in mind is naive.hoon. Lib naive. We'll take a look at it. This is a special case library that has a subset of hoon in it that is used when it does the Ethereum oriented calculations. So tiny is like the minimalist definition of hoon and hoon values. It's like this is like absolutely only the bare minimum of things you need to have like a functional hoon. So most bits and pieces aren't in there. Like all of buy is not in there, but there's like apt, del, put, and get, and nothing else. And it has set and map operations, and like that's it, right? Like this is so tiny is like this this very, very stripped down version of this. And then naive uses that because naive is the header that is used when we do Ethereum ETH Watcher calculations on things. So a lot of hard-coded things and a lot of cryptographic calculations on the basis of it, but it's a stateless library, still a bunch of stateless cores for manipulating keys and figuring out how to turn what you know from Ethereum into information about Azimuth points. Then there's a lot of shared types in LOL. I think we can kind of skip over those. It's like networking and spawning stuff. Like, you know, is the spawn proxy valid? That kind of check. Well, the PKI and the PKI definition is interesting. That's in LOL. Okay, so this is what Urbit says are the necessary types to have a public key infrastructure. So it has information about like a signature. So anywhere you see an oath, which you'll see if you look around, an oath is a signature. Means that someone signed it, and then you have to, you know, ultimately it's a number. You have to decide what to do with it, but that's that bit of information. That's interesting. So you have like a lookup of a key of a name to a from an ASCII representation of something to a Unicode representation of something, because Ethereum permits that kind of information. Yeah, so this is, you know, the short version of if you're going to sign things on a PKI, what are the kinds of things that it wants to know and have available here. And then the other thing to look at is bootstrapping. So Jael is one of the very first veins that gets started. It started in the larval Arvo phase because you have to obtain identity, which means you have to check the key file very early, right? You can't mature into adult Arvo until you know whether or not you are the person that you were told you are when you booted. And so this gets, this dawn event is the thing that gets put together here. And so this is the information that has to be obtained and then injected into your system. So there's your key file seed. There's your sponsorship, the information you know about them. There's your czars. This is your map of information about the galaxies that you know about. etc. The Ethereum, the Azimuth block, you know, if you're doing like a HEP load Azimuth or whatever it was, you know, what's the information you currently have when you boot, and then you can play forward from there. Jael's interesting because, like Gall, it's a landlocked vein, but it does receive this information. It's landlocked in that it doesn't talk out, but it's sort of not landlocked in that things like Dawn talk into it. Like, here's the validated boot event. It builds that information from Azimuth. There's like ETH RPC stuff that it goes and pulls, and then it actually builds and injects. There should be I guess Dawn Vent is only constructing the event, and then this is going to get injected. Somewhere else it gets injected. Let's see where that injection happens. Okay, the king injects it, which makes sense. Yeah, so then you get your Dawn event, and then you boot with that Dawn event once you have that information. That makes sense. That's all put together there. So there's a lot of checks and pulls to grab the right information and bring that in. Other than that, this is not there's really not much to say about the runtime. You know, like we're actually, you know, we've hard coded in, here's my L2 roller information. You know, here's the public key request. So, you know, you can go look at what's going on with the Ethereum JSON RPC. You know, are we pulling information? Where's all that going to? So yeah, it's just how do you request information directly from the Ethereum state and get what you need. Okay. Questions right now?
I've got one broad one, which is about sort of like, I guess, boot sequence. So you're talking about how Jael has to, it's one of the earliest booted veins because it has to attest that whatever ship that we're booting actually has the identity that we say it does, like that this is the key actually associated with this identity for booting a planet or something like that. And it uses Gall, well, at least to watch the Ethereum state. I don't know if it uses it to just get Ethereum state in general, but like there's a bunch of things with, like it's similar to Khan in that it uses Gall, like a Gall agent for some of its state and monitoring. Like, does this mean that Gall, like, does Gall also precede Jael? Like, is Gall booted earlier than Jael as a result of this so they can get ETH state, or how does that kind of work?
No, excuse me. It's not, because this constructed Dawn event pulls the information that you need prior to that point.
So, like, does Bear just directly talk to, it looks like it goes
Yes.
to some, yeah, like Dawn ETH RPC, it just directly goes to an RPC endpoint to grab some of this information that it needs.
Yeah, so we could chase this down. Yeah, so it's going to end up being a curl.
Yeah, yeah. It's just going to
And
get
then
some JSON
you're actually just going to hit that endpoint, and yeah, curl easy get info. Like we're just hitting an endpoint and asking, you know, we're going to be blocking. There's a blocking up. We're waiting till we have that information back, and then we figure out what to do with it.
So, like, Bear itself will perform the operations with the, like, so I guess as we're booting, Jael will get information directly from Bear, like maybe it'll be injected via like a raw card or something like this, or some information will be provided to it that says whether or not that attestation of whatever key that it has is actually correspondent to what's on the Ethereum blockchain. And then, like, once it's booted up, then it will like go through Gall to continue to get information from the Ethereum blockchain. Is that like the right way of thinking about this?
Yes,
Okay.
that's what's happening. Gall's going to maintain that state for you once you've, and this is why you can throw away the key file as soon as you've booted.
All right. Once you've attested once, you don't need to attest again, right?
Yeah, and you have a way. of processing everything after that point. I mean, it's kind of funny because there's so much of Urbit is built around handling the single instance of booting. Like there's a lot of infrastructure of like, can I boot correctly? And then once you boot it, you never need this information again. All right. Like there's all this code that's sitting there that you never are going to touch again once you boot it.
Yeah, and there's all that like very nuanced stuff that I still don't fully understand it. The like full like the 5 stages, right, of like going from the larval stage to the mature Arvo and this sort of thing. Like I guess you go through that full process when you're booting for the first time, but then various subsets of it when you have an upgrade and like if it affects Arvo needs to rebuild and this sort of thing. There's a lot of like complicated infrastructure around these. Well, these are like the big things, right? These are the big promises of Urbit that you're going to be able to like just upgrade it and it'll just work, right? So it makes sense that there's so much attention paid to those pieces.
Now I wonder if maybe the right way to do it is to have like a light client where it's like you have to run like a full var to boot. And then there's a light client you can run once you don't have to do that anymore.
That would be interesting. Yeah, you just lop off all the boot sequence pieces.
Yeah, and then you just have pure start.
Yeah, that would be interesting. I had one sort of like philosophical question I also have about this is that now that we've looked at Con and at Jael, like they both share the similarity in that they use Gall for like they sort of like well, I guess in the case of Jael, it uses an agent, a Gall agent specifically, to get updates on the Ethereum blockchain, and Con like goes through Spider to be able to actually run threads and so forth. What like in general, what is the philosophy behind like when a vein should be using a Gall agent to be like doing things, like versus doing things on its own?
I don't know if there's like a root answer to that. Like I don't know if there's a rule you could write down that would always give you that would yield like why we do it this way now.
What would then be sort of like some of the reasons? Like in the Con case, it's a little more obvious to me because like there was an existing, like it started out as Spider, right? Like an idea of like how would we write something, like as often is the case for extensions to the to core or the kernel. Like we write it first as a Gall agent to just sort of like field out what would this look like, what would the interface look like, and so forth, and then like it matures into its own vein. So I could see why that would. I can see in the Con case more readily why it is the way that it is, but I guess it's not so clear to me why like Jael itself does not do all of this monitoring of the Ethereum blockchain, like why it uses an agent to do this sort of stuff.
I mean, I think you could. So I think you could probably integrate all of this into Jael without too much trouble. You know, rewrite Jael, make it behave in a certain consistent way. But that would couple you more tightly to Ethereum, right? Like the idea that Jael knows about Azimuth, but is not tied to any particular instantiation of Azimuth is powerful, right? Like that's closer to 0 Kelvin than relies on Ethereum explicitly. Right, like that's the difference there from what Spider does with Con.
Yeah.
Right, like you don't want to hitch your wagon to Ethereum for time and all eternity because now you're at 0 Kelvin and you baked Ethereum into what you're doing here.
Right. Yeah, so I guess the idea is abstraction of the PKI layer from the Jael vein itself. Like Jael should only be handling public private keys and all this stuff with like life rift moon infrastructure, that sort of stuff, monitoring moons and comets and that sort of stuff. So it's abstraction from the Ethereum blockchain, is what you're saying. That's why we have it this way.
Yeah.
Okay.
Yeah, and this lets you stage things down. And then you have App Azimuth and you have App ETHWatcher, because App ETHWatcher is actually talking to any, you could monitor anything with App ETHWatcher. Right. And then App Azimuth is actually saying, okay, well, we're actually watching Azimuth.
Yeah, it's like specifically for that contract, or that contract and the state related to that contract, rather than just give me Ethereum blocks that just have arbitrary bits of information.
Right.
Okay. Okay. Yeah. I think those are the big questions I have. Thank you.
Grant, you got anything for me, or is that a wrap?
I think that's a wrap.
All right. We made it.
Well, it's not
This
over
is
yet.
one-
We got to do those homeworks. So.
Well, okay. So yeah,
it's over for you now. Oh no. You
Well,
have to grade
I gotta come back and grade. And actually have to figure out what I want to do with homework on this one. Okay, so what I decided, there's going to be like a Core Academy like student, Gora. There's going to be a finisher. I don't know if I have a better title than that or not. And that's for doing all the homeworks less 2. We probably have about 10 or 11 homeworks, since I have a few that I skipped. And they're not all the same difficulty. And that'll be like a Core Academy finisher. And then there'll be like a Core Academy maximalist if anyone does all the homeworks. That's the shiny platinum badge. So yeah, January 28th. I'm gonna hold some office hours in January. Just for people to drop in, and maybe I'll see if I can get Joe or someone to hang out in those and answer hard questions. So
I think the homework that I skipped so far was homework 2, where you need to write a custom aura.
okay. I think that's actually one of the easier ones. But,
Oh, really? Okay. Maybe I didn't delve in.
well, I mean, there's like the really easy ones, which are like, here's a list of things I want you to do and then certify that you did.
Yeah.
And then there's the ones that's like, you got to write something. I think that writing a custom aura, it's not hard in that it's pretty self-contained. Like there's like 2 places you have to change to make that work.
Okay. Yeah, because I did the custom rune, and I mean that was trivial.
Right. It's surprisingly easy to. Yeah, that's right. You PR'd it against.
that was really funny.
Yeah. I didn't know that
It's like,
submitting a
I don't know if we actually need a.
It's so
Well,
funny, all these people submitting like, I want to be able to do a 9 tuple, 10 tuple, just
if only there were a general way to write this problem. Oh boy.
Yeah. And then it looks like homework 12 is, I mean, there is no homework 12, and then homework 13.
I'm going to come up with something with comment, messing around with comments one way or another.
Okay.
I think it's not going to be a hard one. It's just going to be one where it's like, there's like 2 or 3 moving parts that you have to figure out how they go together. Homework 11 was the write a goal.
Right. Yeah, I'm still working on that one.
that's one of the hard ones.
Oh,
I think as these things go. I think it's valuable, but that's a rough one. It's a big one.
Yeah, that homework is what really got me to look closer at core variants, because I realized I've just been skimming over all of these like Ketvar runes, and like I need to actually confront them and figure out what they're doing. So,
well, you had actually, was it you who was running into the case where like, why don't these 2 nest? And it's because they're gold.
yes.
Okay.
Yeah. So specifically, my question there was, if you just have 2 gold cores and they have different return types, like I would think, oh, it's the same number of arms and it's the same sample type. So how does the compiler know that they don't nest? And I guess it knows that they don't nest the same way that it knows any other sort of mint error, where it's like, it just follows the logic down until it gets to the return type, and then it can tell, oh, it's not returning the same thing. And that's just a special thing that it checks when you try to cast cores to each other, I'm assuming.
Right. I mean, one of the things about variance is, one of the things that I think makes it hard to think about is it's treated as if it's a fundamental property, but it's actually a fundamental property of how two cores relate to each other.
Right. Yeah, that was really tripping me up. Because
Yeah.
it's like the core itself is not invariant or bivariant. It's like, yeah,
Well, it is, but yeah.
yeah. It's the way that another core relates to it, and then variance describes the rules of the type system, right?
Right.
Yeah.
Right. It only becomes an issue when they interact.
Yeah.
Like you can do whatever, like when you have a core by itself, you can do whatever you want to. As long as it's just that core. It's when you try to put another core into it or put into another core that things break or do
Right.
things that surprise you.
Yeah. Yeah. I found Joe's explanation that he dropped in chat to be really concise and helpful. Where he said, like, oh, this pertains to the payload, this pertains to the sample. Yeah.
Yeah, I dropped that in an issue on the docs so we can figure out how to integrate it. I have this dream that I've as yet been able to realize that we'll come up with some like really intuitive real world analogy that will like just solve this problem. That it's like, oh, it's like the thing we do every day when we do XYZ. But I have not come up with one yet. Like they're just weird.
Yeah, like there's the analogies with, oh, a tree is a plant, and so you can return a tree and everything. It's not perfect, but
There's some swizzle on that I think could work. But it has to do, like, you have to figure out how to integrate that with samples and payloads. Somehow there's got to be something that like nests as a sample but not a payload in terms of like how it inputs and outputs things. There's some real world example that's hard to come up with.
Yeah.
And I will say that homework, the one where you have to like write the scamps, that was probably like that, and then like writing knock from scratch. And there was one other where you go like really deep into the weeds that were just like very elucidating on like how does this thing actually work. So it's definitely one of the harder homeworks, but I found it to be one of the more like edifying, just in terms of like learning a whole bunch of new things about how the system works. Because you have to like really you get confronted with a lot of things that you don't understand when you're working on it.
Yeah.
Like this core variant stuff and so forth.
Well, that's the hope.
Yeah.
The hope is you do Core Academy, then you understand things really well. Yeah. I mean, I think that there's definitely pieces missing. There are still swaths of Urbit that we have not actually, I think we've pretty much touched everything, but there's a lot of places where you can go a lot deeper if you need to.
Yeah, like Sidney and I were talking a couple weeks about how I don't think hood generators are documented anywhere.
Yeah, they just kind of like you have to like look at hood itself to figure out how all these things work, and that's its own rabbit hole. And I don't fully understand still how the hell. Yeah, that whole dojo stack is very complicated, and like I think hood is kind of part of that. And it just all kind of works somehow, and yeah.
I mean, this is have I talked about the thread shell idea?
I don't think so.
Yeah.
So this came out of a conversation with Anthony a while back, but I think we should have a shell that is actually every command in it is a thread. And then you explicitly have this queue of returns that then you can manipulate or decide what to do with.
Oh, is this what you're talking about, kind of like with keeping track of cards? Like this be easier to do this way? Or is this something separate? Because right now, if you pass a card,
right.
if you pass a card through Dojo, like you can't keep track of the result, right? It just kind of gets dropped because it doesn't know where to send it to, or it doesn't have like a specific duct to pass it back to. Whereas if you were to run these as threads and have a queue of these things, you can more easily manage like the returns of those threads. Or maybe it's just the same level of complexity, but we just don't do it in Dojo for whatever reason.
Yeah, I mean, I don't think it'd be like fundamentally more complex than Dojo, but I think it would give you some capabilities that are difficult to do in Dojo right now. Like one of the things that I think that Dojo, like the fact that you can pass a card but you can't receive it, like you can't do anything with it, is kind of a problem in a sense, right? Like it actually makes it hard to figure out what's going on. And you want something that feels more like Bash, in that Bash is like I can handle an arbitrary return in Bash and pipe it or do whatever. Like Dojo doesn't let you pipe things. I mean, I can redirect to a file with tar, but I can't really pipe it from one thing to another.
Right.
Right. And like the ability to do that would be, I think if you had a thread-based thing, would be a lot more straightforward. And so then you'd actually be manipulating, and then see, this is one place where Urbit would actually really shine, because you would always be manipulating values rather than, okay, so Bash, right? So Bash actually doesn't even have a notion of a string.
Yep, Bash is wacky. Yeah, go ahead.
Because Bash doesn't even know about locales, which change string encodings. Bash literally only deals in byte streams. And yet, with just byte streams that we can pipe into each other, we can do an awful lot of things. And so if we can actually do this in Urbit, where we have a shell that deals in nouns, now we can actually start to do some really interesting operations that you can't do anywhere else. You'll be able to build pipelines that won't require you to do raw text processing. Like you will actually have a noun that is a representation of the data that you can manipulate as if it's data, rather than, it's like getting an object back or something.
You have better serialization of your data. Like you don't have to do all that weird Bash stuff that you have to do with like word count, and you have to have a whole bunch of intermediary applications that examine text files or text streams, right?
Right. Well, and even like deserialized data, right? Like in that I don't have to serialize to do interesting things with this data, and I don't have to drop to a text representation. Like I actually I have the data.
Yeah, you just have it direct. It's just a noun.
Like that seems pretty straightforward.
And that
to
does
use once you have it.
And I think that is a big need for Dojo to be able to do streams, like to be able to do what the equivalent of Bash does with like piping things, right? And that, like, as we talked about in the con lesson, that's like a natural thing that like threads do, is like you can spawn a thread and that can have like, when it succeeds, then run this other thing, right? Or like run this thing with the result of this thing. It's like you can chain these things together in a very not like a intuitive way, and like you can chain them together in a way that you cannot currently do with Dojo commands. Like you have to like run it, pipe it to a file, then read that or something. Like you have to submit all these different commands rather than just having a single command that does all these things.
Right. Yeah.
How hard do you think that would be to do, to have like Mojo or whatever you would want to call it, the thread Dojo?
Mojo would be a fantastic name.
Ideally, there'd be a T somewhere in there because it's threaded, like threaded Dojo.
I don't know. Mojo might just work.
It's just like close enough. I don't know what the M
I was thinking of calling it Bath instead of Bash, but Mojo is a great name. No, I mean, I think it's a good example of something that would, like, if you wanted to proof of concept it, you could do it in like a month. But to really make it useful is going to take longer.
Because Dojo is like pretty complicated. But yeah, setting up some.
Well, you wouldn't re-implement
Yeah, the whole stack of Dojo.
The whole stack of Dojo, you'd reuse a lot of it. You just issue it as thread instances rather than hood things.
Mhm.
And that would also get you away from the different syntax of col and bar and all this stuff.
Yeah, that's some other. That was something
Which,
else. Kev
which
and I
is
were
just
talking
not
about.
intuitive, right? Like, why is it less ls, but it's bar CP? If you know the system, you know why, but it's like, it's not a good, there's no mnemonic there.
Right. Yeah, it's just we use some symbol, whatever the next symbol was to do this. It doesn't have the same level of what's it called, consideration that like runes have, or like what is for your if and else, like that sort of thing, where it's a little bit more intuitive. Like the Dojo
Yeah.
stuff is a little bit more arbitrary.
Yeah. So. All right. Well, let's call that a wrap for Core Academy lessons then.